All right, happy Sunday. This is just a short video about completing the square. Completing this square basically is, if you were to visualize it, is if you had a partial square, how many pieces would you need to complete it so that it would be a perfect square? And remember, a perfect square is all sides are equal, right? So if it's 4 long, then it has to be 4 tall. If it's 5 long, it has to be 5 tall. Okay. Now, completing the square is one of the 4 methods that we're going to be learning how to solve quadratics. Quadratics are anything to the power of 2. So ax squared plus bx plus c. This is called a quadratic. The shape of that quadratic is a parabola going either up or down. So we've been learning about solving by factoring. I will be reviewing solving by square rooting in class, and solving by completing the square I will also be doing in class, but I wanted you to kind of get an idea what this look like. Okay, so if you've never seen algebra tiles, then I need you to kind of visualize how that looks like. Okay, and algebra tiles are basically manipulatives that help you see what the picture looks like. So an x squared is basically a big square because it's x long and x tall. Okay. And an x, oops, why is this erasing here? Okay, so let's try this again. X, all right, never mind. Not sure why it's not working. X is x tall, but only 1 wide. And ones are 1 tall and 1 wide. Okay. So if I were to visualize what this looks like, if I had x squared plus 4x plus what would that what be? So that if I were to draw these tiles, algebra tiles, it would make a perfect square. And then how would I rewrite that x squared plus 4x plus what as a perfect square binomial? Okay. So first thing I want to do is x squared is a big X. And if I have 4 x's, it's only fair that I have 2 going to the right and 2 kind of going at the bottom here. And so if you look at what this picture looks like, notice it kind of looks like an upside down L or an R shape. That is not a perfect square. To make it a perfect square, it has to be the same length going up and down as it is across. So notice I'm missing this tiny little piece right here. What would fit into that perfectly? Well, I think I would need 4, 1, 2, 3, 4, 4 little 1 tiles. So that's x squared plus 4x plus 4. So if I take a look at how long it is, okay, and how tall it is, it should be the same length. Well, x squared is x times x. X is x times 1. X is x times 1. This x at the bottom is x times 1. And this x at the bottom is x times 1. So notice that this is x plus 2 long and x plus 2 wide. So I can rewrite x squared plus 4x plus 4 as a x plus 2 quantity squared. So if I look at x squared plus 10x plus what? Okay, what is that what? So it would make it a perfect square. Well, x squared is a big square, right? And if I have 10 x's, it's only fair that half of them go to the right and half of them go underneath here. Now notice this shape isn't a perfect square. It's kind of like an upside down L or an R shape, and I would rather have a perfect square. So however tall it is, it should be the same length as how wide it is. So see this little blank right here, this bottom right corner, I want to know how many little squares can go in there to make it a perfect square. Well, if I go across and I draw my columns up and down, notice I would need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25 of them. So I need 25 little squares to complete this square, big square, right? So I notice that x squared is x times x. And each one of these x's is x times 1. And same thing going across on the top. It's x times 1. So this height is x plus 5 tall. And this length is x plus 5 wide. So x squared plus 10x plus 25 can be written as x plus 5 quantity squared. I want you to pause, or actually an ed puzzle, I will pause for you. I want you to determine what is this missing spot right here. X squared plus 8x plus, what would this missing number have to be? How many little squares would you need to complete the square? And then how would you write this as a perfect square? Okay, so let's take a look at the next part here. So just making sure you weren't sure of the steps. The steps are, it's really important that when you're solving, it has to be a power of 2. Ax squared plus bx plus c. So notice it's x squared minus 12x plus 13 equals 0. So it's important that this term right here has to start with a 1. If it doesn't start with a 1, what is going on with my highlighters and stuff today? Okay, not sure. That's interesting. So it's really important that this begins with a 1. Okay, so now if it begins with a 1, we want to write this in quadratic form. Quadratic form means you take your constant and you move it to the right. Okay, again, I don't know why this is not working. Okay, so x squared minus 12x equals negative 13. Because when I move that positive 13 over, it becomes negative 13. And hopefully you saw that the rules is that you always take the middle number. This middle number is negative 12, not the variable with it, but the middle number. Okay, you divide by 2, and then you square it. That's the number you add to both sides. So negative 12 divided by 2 is negative 6. Negative 6 squared is 36. So this is the number that I need to add to both sides. Okay, so I'm going to rewrite this problem as x squared minus 12x, but I'm going to add 36 to the right, or to the left, equals negative 13. And since I added a 36 to the left, I also have to add a 36 to the right. Now I want to write the left side that is a trinomial. I want to write that as a perfect square, kind of like 9 can be written as 3 squared, or earlier the x squared plus 10x plus 25 could be written as x plus 5 squared. So since I want to write this as a perfect square, first thing I want to do is I ask myself, what times what makes x squared? X times x is x squared. And then I ask myself, what times what what times what is 36? 6 times 6 is 36. And whatever the sign is in the middle, I drop it. So if it's a minus sign in the middle, I put a minus. If it's a plus sign in the middle, I put a plus. Okay. On the right-hand side, I want to combine the negative 13 with the 36. And negative 13 plus 36 is 20. Last step I want to do is I want to square root both sides because you are solving for x, so you're trying to get inside that parentheses squared. So I want to take the square root of both sides. So if I square root the left, I have to square root the right. And when I do that, I get this square root, and this square will cross out. So I'm going to get x minus 6 equals plus or minus the square root of 20. The reason why it's plus or minus is because x squared tells you that you could get possibly two values, right? And so the last thing I want to do is I want to solve for x, so I'm going to add 6 to both sides. So x equals, and then you can't actually combine that 6 with the square root of 20 because 6 is a whole amount and the square root of 20 is a partial amount. So it's 6 plus or minus the square root of 20. Now we are going to change that square root of 20 because you could actually break it down. 20 breaks down to 5 times 4. 4 breaks down to 2 times 2. And square root means pairs. What do I have a pair of that can come out of the square root? Well, I can factor out a 2, and I'm left with a 5. Okay, so I need to rewrite 6 plus or minus the square root of 20 as 6 plus or minus 2 square root of 5. All right, this last one right here, problem number 2. Sorry, I wrote so big that I wrote all over it. Now, again, I want to solve by using completing the square. So it's important that first thing I do is that my equation, my x squared, my coefficient has to begin with a 1. And right now it begins with a 2. I don't want 2x squared. I want 1x squared. So if I want to change that to a 1, I got to divide by 2. So if I divide that by 2, I have to divide everything by 2. And I'm left with x squared equals 59 minus 6x. Second thing I need to do is I need to get this ready. So if I take a look at the steps again, it says I need to write it in quadratic form, which means the constant's on the right, but all the variables are on the left. So if the constant is on the right and the variables are on the left, that means I need to move this negative 6x to the left. So I have x squared plus 6x equals 59. The next thing I want to do is I need to figure out what number do I need to add to both sides to complete the square. So I always take the middle number, divide by 2, and then I square it. Well, 6 divided by 2 is 3. 3 squared is 9. So I'm going to add 9 to both sides. And if I add a 9 to the left, I have to add a 9 to the right. So now on the left, I have x squared plus 6x plus 9. So I need to rewrite that as a perfect square binomial. And then I want to combine the right 59 plus 9. So 59 plus 9 is 68. And on the left, how would I write that as a perfect square? So pause for a second. So hopefully you realize that x squared is x times x, and 9 is 3 times 3. Because there's a plus in the middle, I also have to have a plus in the middle. Now the last thing I want to do before I solve for x is I need to take the square root of both sides. So if I square root the left, I have to square root the right. So square and square root will cancel. I'm left with x plus 3 equals plus or minus the square root of 68. So now what would I do to solve for x? So pause for a second and think about it. Okay, so hopefully you realize that you would have to move this 3 over. And when you move that 3 over, you would be subtracting 3. So x equals negative 3 plus or minus the square root of 68. Now, the square root of 68, that breaks down into 2 times 34. And 34 breaks down into 2 times 17. So what do I have a pair of that can come out of the square root? Well, I can factor out a 2, a pair of 2's. And what's left behind is 17. So my final answer, instead of x equals negative 3 plus or minus the square root of 68, is x equals negative 3 plus or minus 2 square root of 17. All right, this is your introduction to what we'll be doing in class for session 6. Have a good day.